Dear student, today I am going to explain about normalization, why we need normalization, and what is 1NF, 2NF, 3NF, and mainly what is the difference between 3NF versus PCNF. Normalization. Normalization is the process of organizing data in the database to avoid data redundancy because data redundancy causes several anomalies such as insertion anomalies, deletion anomalies, and updation anomalies. Anomalies in the sense problem. We can't able to insert valid informations in the table and we can't delete the data. If we try to delete some data, it will delete some other data also. So that is called a deletion anomalies and update anomalies. If you want to update one thing, it should be updated in all other things also, all the other wherever the data available in all the databases, it should be updated, right? So this is called updated anomalies. So several anomalies such as insertion anomalies, deletion anomalies, and updation anomalies. So to avoid all these kind of anomalies, it's important for us to normalize the table. Normalize is nothing but decomposing the table into a small table as much as possible for us without deleting the valid informations, without violating the valid informations. That is called normalizations. Okay, so first we will see about what is insertion anomalies. Let us consider this table: employee ID, employee name, employee address, and employee department. So here initially one company initially recruited one new guy to the particular industry, but not assigning particular department to the industry. So in that case, if this column won't permit the null value, it is not possible for us to enter the newly recruited employee into this table. This is called insertion anomalies. Okay, so next we will see about deletion anomalies. So here let us consider employee name Shweta belongs to the department D880, right? So now the industry want to move from this department to another one department. That means they want to delete this department and they going to make use of, they're going to use another one department. Okay, so when we try to delete this one, it will delete Shweta details also. Actually, they're going to use this employee in the newly migrated department also. But in this case, if you try to delete this department, it will delete the Shweta also. That is called deletion anomalies. And updation anomalies, for example, if the Reshma address changed, okay, so we need to change her address in one table, right, one row. Now we need to update it in this department also. Wherever Reshma details are found, we need to update all the rows also. That is called updation anomalies. Okay, so to overcome these problem, insertion anomalies, deletion anomalies, and updation anomalies, we need to perform normalization. So first we will see about, so these things we saw already, right? Update anomalies, insertion anomalies, and deletion anomalies. First I will discuss about what is 1NF. For a table to be said to be in 1NF, it should be properly filled, in the sense the intersection of rows and column should be atomic in nature. It should have one value. But here let us consider this situation. John mobile number 2, it should not be like this. It should have only one value. So we need to repeat the John value again also. That is called 1NF. Okay, so here consider to make that table in 1NF, we need to repeat the John details again. That is called 1NF. Okay, next I move on to 2NF, second normal form. Yeah, table is said to be in 2NF. It is already in 1NF. It should be in 1NF, and then no non-prime attribute is dependent on the no non-prime attribute is dependent on the proper subset of any candidate key. So here let us consider one instructor. So instructor can teach 3 or more subjects to the students. Let us consider 111 instructor ID going to teach a data structures, database management systems lab, etc. Okay, so in that cases, wherever that instructor ID comes, that instructor age is also repeated, right? That is redundant repetitions there. So in order to avoid that, we need to decompose the table into two. That is the basic idea of normalization. We need to decompose the table into a small table, as many as possible for us, without violating the informations. So in order to make that into 2NF, okay, listen. After 2NF, I'm the just that before this table decomposed into two different table: instructor details table and instructor subject table. Okay, now let us consider third normal form. Okay, so table is said to be in third normal form. It should be in 2NF, and if there is any transitive functional dependency is there now, it should be removed. What is transitive functional dependency? Uh, what is transitive functional dependencies? Wait. A which implies B, B which implies C na, we may form so A which implies B. This is actually what is now functional dependency. Value of A decides the value of B. That is nothing but in table A attribute A determines the value of B. That is called a functional dependency. The value of A which implies value of B. And another one functional dependency, value of B which implies value of C. If these two functional dependency exist in one relation, one table now, we may form A which implies C. Sorry, A which implies C. Okay, not B. A which implies C, A which implies B, B which implies C, na A which implies C. That is called transitive functional dependency. It should be avoided. It should be avoided. For a table is said to be in 3NF, that kind of transitive functional dependency we need to remove. Okay, now I'll explain the same concept with one example. Okay, listen here, employee ID which implies employee ID, employee zip code. That means postal code determines employee state, employee city, employee district, that we know very well. Okay. Then employee ID is based on employee zip code. Employee ID decides the employee zip. Then we may form if these two functional dependency. Then employee zip is based on decides the value of these three attributes. These three attributes. Employee zip code decides the value of these three values: employee state, city, and district, right? And then employee ID determines the value of employee zip. If these two functional dependency exist now, we may form this functional dependency. For a table is said to be in 3NF, we need to remove this one. That is called 3NF. We need to remove that transitive functional dependency. So therefore, after removing that 3N, that transitive functional dependency, our table look like this. Okay, employee table and employee zip table. Okay, employee table. After 3NF, this previous table split into two tables: employee zip, employee state, employee city, employee district, and right. Next, I am going to explain about BCNF. Actually, BCNF is said to be more stronger than 3NF. For a table is said to be in BCNF, it should hold the functional dependency X which implies Y, where X should be the super key. Okay, listen. What is the difference between 3NF and BCNF now? Let us consider. Okay, X X, which implies Y. X, which implies Y. Na? What is the meaning of this one? The value of X determines the value of Y, where X should be the super key. Okay, and also Y is a prime attribute. It is in the case of 3NF. What is the difference between in order to illustrate about the difference between 3NF and BCNF? These two exist in the case of 3NF. X, which implies Y, where X should be the super key, and Y is prime attribute. This is in the case of 3NF. But for a BCNF, okay, we no need to hold these two conditions. It hold only this one alone. This one alone. X should be the super key. So here it was here functional dependency X, which implies Y, where X should be the super key. These conditions only hold in the case of BCNF, whereas in 3NF either this or this can hold. The table is said to be in a 3NF, but for a table is said to be in a BCNF, it should hold only this condition only. That is called BCNF. Okay, in order to show the difference between 3NF and BCNF, now I will explain what is BCNF with the use of the following table. So employee ID, employee nationality, employee department, department number, and number of employee. To make the sent into BCNF, the table is split into like this. So I already told you. So normalization, the main aim of normalization is to decompose the table into a small table as many as possible for us without violating the informations. So this is called BCNF, and we discussed about what is the difference between 3NF and BCNF. Okay. Okay. Stay home, keep social distancing. Thank you for watching this video. All the best for your examination. Thank you.